Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video, we're going to talk about properties of logarithms, and specifically, we're going to be talking about expanding and condensing. So there's 3 rules we need to cover before we start really talking about examples. The first rule is called the product rule. So in this rule, our condensed version would be log base x. Now it doesn't have to be an x, right? We could have a number in there, but log base x of m times m. Okay, that's kind of how we would read that. Log base x of n times m. Now obviously m and n I'm just using as a placeholder for, we could have other letters there or other numbers, but this is just basically an example to help you see the rule in action. So if we started with this form, which is a condensed form, and I know it's condensed because I'm multiplying my values here, I could rewrite this in a different way, that it is still equivalent to the same value, but it's an expanded version. So think about condense means to make something smaller, and expand means to make something bigger, right? So the condensed version of log base x of n times n, I could rewrite as an expanded version of log base x of m plus log base x of n. Okay, so notice, I know there's a lot of letters and m's being thrown out there, but notice what's happened here. We started with a multiplying, and we rewrote each part that we multiplied as its own individual statement, and we added them. So the real takeaway point from this is that when we multiply in condensed form, we are going to add in our expanded form. So multiplying and adding, those have a relationship. Our next rule is going to be our dividing rule. So notice for this one we have log base x again. This time it's m divided by n. And that's our condensed version. When we are dividing, that's going to be the condensed. And then we could rewrite that in an equivalent way, but in an expanded version. And notice this time we take our 2 parts, m and n, we write them each with their own log base, and we subtract. Okay, so the takeaway point being here, when I divide in my condensed version, that I am going to subtract those values in my expanded version. Our last rule is called the power rule. So log base x of m to the power of n would be equivalent to n times log base x of m. So notice what's happened here. We had this tiny little exponent in our condensed version, right? And then over here in our expanded version, all of a sudden that n jumped out, it got big, and it jumped out into the front, right? So when we go from a condensed, where we have a little tiny exponent, we just need to expand by jumping that exponent out front, making it big, and we're now multiplying. So again, those takeaway points, before we start actually going into examples with this, the takeaway points are that when we are trying to expand, when we're expanding, we know multiplication goes with addition, division goes with subtraction, right? We saw that here. Multiplication goes in with addition, division goes with subtraction. And when we have a little tiny exponent with that m, we just know we jump it out to the front, okay, just like we did here. We take this, we jump it out front, and that gives us the expanded version. When we want to do the reverse, right, because these rules work this way as well. So when we want to take an expanded and condense it, we want to make it smaller, we take the addition and we make it multiplication. Okay, we would take our subtraction and we would make it division. And then if we had a large, n out here being multiplied, we would take that n and we would condense it. We would make it tiny. We would put it up for here with the m and make it a little exponent so that it looks like this. Okay, so expanding means making bigger, making longer. Condensing means making it shorter and more condensed. Let's look at some examples where we would need to expand. So notice I've given you 7 different condensed examples, right? So these are all in condensed form, and we want to expand them. We want to write them in a longer way. So our log and our base doesn't change. So since this is log base 5, that's going to stay the same. But what we have to look at is what's the relationship that's happening here. So this is 2 times x. And remember we said times goes with adding. Hopefully that's what you were saying. So we keep our log base 5 of 2 plus, and I say plus because we were multiplying, so now we're going to add log base 5 of x. So the important thing to understand here is that these two are equivalent. They're saying the same thing. We're just rewriting it in 2 different ways. Okay, so that's important to keep in mind. We're not solving anything. We're just rewriting. We're expanding right now. All right, let's try this one. So log base 3 of x times y times z. Now hopefully you're thinking multiplication going on here. So when we multiply, that means when we expand, we're going to add. So we're going to do log base 3, and the first one, that's not going to change, right? Now the first value was x. So we'll go ahead and do that one. And then because it's x times y, remember times means add, so we're going to do another one. So log base 3 of y. And then look, we have another value that we're multiplying. This time it's z. So we're going to do an addition for another one. Log base 3 of z. So this is going to be our condensed version, and then we have expanded it into this version. Now for this example, notice this is log base 2 of 3 divided by 4. Now when we divide in our condensed version, we are going to subtract in our expanded version. So our base, our log base 2, no change there, okay? And then we take our first value. So log base 2 of 3, we'll start with the numerator, and we're going to subtract log base 2 of 4. So in the condensed version, we were dividing, and in our expanded version, we are now subtracting. Now this next example could be a little tricky, because hopefully you're noticing that we've got our log base 3, so I know that's not going to change, but I've got this 5 times x divided by y. So I've got both multiplication and division going on in the same problem. So we're going to write this as, it's okay, we're just going to have an addition and a subtraction. So we'll write our log base 3, no change there, and we'll take that first value in the numerator, 5. And what's happening between the 5 and the x? Well, those are being multiplied. So remember, multiplication goes with addition. So we're going to add another log base 3 of x. So these two are being multiplied, right, in the condensed version. But then we've also got this division going on. So it's these subtracted, because we're doing divided by log base 3 of y. So we've got addition and subtraction going on, and that's okay. For this next example, we've got log base 6 of x cubed. Okay, so hopefully you're noticing, oh, what do we do when we have an exponent again and we want to expand it? Well, we want to take the tiny condensed exponent, and we want to make it bigger and throw it out front. So this is really 3 times log base 6 of x. Notice we just did a little movement there with the 3. We just switched its position, so now it's a expanded version. For this example, we've got log base 7 of 2x squared times y. We've got some multiplication going on in here, as well as an exponent. Okay, so we've got to be very careful though, because that exponent 2, I can't just throw that out front and then call it a day. That 2 is only with the x, right? So that's x squared. That exponent of 2 does not go with that 2, and it does not go with that y. It is only for the x. So in this case, I'm going to go ahead and write our log base 7, right? Oh, I put a z. That was weird. Log base 7. That's not going to change. And we'll start with that first value, 2, right? So log base 7 of 2. And then I want to multiply that by x squared. But remember, we're going to take, for this time, just for this x section, we've got to take that 2 and put it out front, but only for this one. So we're going to do an addition to show that we're multiplying, and we're going to put the 2 big out front. So 2 times log base 7 of, what was the base? X. You still have a times y. Remember, times means add log base 7 of y. Now for this last example, this is something that they will tend to throw in there. And if you are looking at that thinking, what is that? You may want to review my video on going from radical form to exponential form and vice versa. So I'll make sure to link that video. But just as a quick refresher, if you remember, but you just need a second, a good rule of thumb for these problems is when we have a radical like this, so this is a cubed root, log base 2, cubed root of x squared y to the 9th. So there's a lot going on here. Remember this rule. The flower is the power, the root is the root. And there's a very terrible picture of a flower, a fraction bar, and the root. Okay, so the root is what's in the little check, right? In this case, a 3. And the power is the flower, which is the power. So in this case, x squared. So we would rewrite this. First thing I'm going to do is change this from a radical to an exponential form. Then we'll worry about expanding it. Let's just change the form first. So log base 2, not going to change, of x to the flower is the power, 2 over root is the root, 3. So that's x to the 2/3 power. And I'm going to do the same thing with y, right? So we're multiplying these. So you could put a little times here, or you could just write them right next to each other, right? Because that implies multiplication. The flower is the power of 9, and the root is the root of 3. So this is really, I'm just going to write a little equivalent here. Log base 2 of x to the 2/3 times y to the 3rd. 9 divided by 3 is 3. So now I want to take this, and now I'm back to the original thought of expanding. So I can take this, and now that I've got little exponents, and it helps when I show in blue, I think, that I can take these and put them out front. Now obviously I'm going to do this one first, and then I'll do the 3 once I get there. So remember, when we're expanding, our log base 2 does not change. And then we've got to think, we had an x, right? But what are we throwing out front? We're expanding. We're making this little tiny exponent, and we're going to make it bigger out front. So this is really 2/3 times log base 2 of x. And then since we're multiplying here, I'm going to use my addition sign. And then now I'm ready for the 3. I'm also going to take the 3 and move it out front, but for this second part. So plus 3 times log base 2 of y. So we've got exponents being brought out to the front as well as multiplying, so we need our addition sign. Okay, let's do some condensing examples. You've got to look at the relationship happening. So I've got a log base 2 of 4 plus a log base 2 of x. Well, log base 2 is not going to change, right? That's my log base 2. Because this is a 4 and then I'm adding the x, that really means, hopefully you're thinking addition goes with multiplication. So this is really 4 times x. And we can just write that as 4x, right? That's implied. That is 4 times x. Okay, if you want to put parentheses there, you can. If you want to put a little time symbol, you can. But the most condensed way to write it is going to be just 4x. And that would be it for that one. Let's look at this one. So for this one, we've got log base 4 of 3 plus log base 4 of 2 plus log base 4 of 10. So our log base 4, no change there, right? That's just going to stay the same. And then I've got a 3 and then a plus 2 and a plus 10. So remember, plus goes with multiplication. So this is a 3 times 2 times 10. And then a lot of students get confused here. They say, do I go ahead and multiply these? Absolutely. Yeah, if we can reduce this, let's make sure to do it. So what is 3 times 2 times 10? Well, 3 times 2 is 6, and 6 times 10 is 60. So we could rewrite this as log base 4 of 60. And that would be your final, most condensed answer. Okay, so for this example, if you do not have a base shown, that is an understood base of 10. We will write it as, and I'm going to leave my answer as just log. I'm not even going to put the 10 because remember, it's understood. So I'm just going to write log. And then let's think 12 minus 6. And hopefully you're thinking subtraction goes with division. So this is really log, understood base 10, of 12 divided by 6. And hopefully you're thinking, well, 12 divided by 6, isn't that 2? Yeah, let's, if we can reduce it, absolutely. So our final answer for this would be log, understood base 10, of 2. And for this final one, so notice we've got a lot going on here. We've got an addition, we've got a subtraction, and we've got some multiplication out front here. So I like to take care of that multiplication first, and then we'll worry about the addition and the subtraction. So if we've got a giant 2 being multiplied out front here, then really we know that is just an exponent of 2. Okay, and if we've got a big 4 being multiplied out front here, we know that's really just an exponent of 4. This one didn't have one, and that's okay. He just has an understood exponent of positive 1. So let's go ahead and just rewrite that to kind of clean this up. So we've got log. Notice I didn't have a base here. That's okay. My base is just going to be 10, right? And I'm not going to write 10 because we've already kind of talked through that. So log of x squared plus log of 2 to the 4th. Now, we could go ahead and reduce that, right? What is 2 to the 4th power? And if you need to bring out a calculator to check, it's 2 times 2 times 2 times 2, but 2 to the 4th power is 16. Okay, so we could go ahead and reduce that to 16. Why not? Let's save some time. And then we are going to subtract log of 7. Okay, so now we want to take care of that we've got addition and subtraction. Let's just worry about these first two. So because it's addition, we know that means multiplication. So our log and base is not going to change, our base 10. And this is x squared times 16, right, in our numerator. And I say in our numerator because I'm already looking over here. I know what that's going to mean. But if you're not, that's okay, if you're not sure yet. Now, I would not want to write x squared times 16, right? We always, in good math etiquette, would allow the number to go first and then our x squared. So 16 times x squared. But then we also have this minus 7. So remember, subtraction goes with division. So then we're going to divide by 7. Okay, so our final condensed version here is going to be log base 10 or log of 16x squared divided by 7. Okay, here's your you try examples. For this one, I've given you the condensed version and I want you to expand it. And for this one, I've given you the expanded version and I want you to condense it. I will post the answers in the video description below. This has been Miss Math Tutorials.